Inequalities, and the difference today, bless you, is that, and I underlined linear in the title here as sort of a hint, the difference in what we're going to be doing today is that instead of just one variable, like yesterday where you get a variable greater than or equal to a number, and you'd graph it on a number line, is that remember, a linear, if we did a linear equation, I'll give you an example of a linear equation with an equal sign, that it would look like this. Can somebody tell me how we would have graphed this when it had an equal sign? This is obviously not an inequality, but an equation, equal sign. How did we graph these? It's the last chapter. Izzy, one way. Okay, one way is to do slope-intercept form. So you can graph with slope-intercept form. What was the other way? The first way you learned. In fact, I taught it to you back in 6th grade. And we did it this way this year too. Before we learned slope-intercept, Diego? Yes, or a table of x, y values. So you can still use either one of those methods. I'm going to be doing slope-intercept form because I find it quicker. But if you were having problems doing slope-intercept form accurately, then you might not want to use that method. However, it is going to be easier to use for this particular thing. So here's what we're doing. This was an equation. We've spent time on that. Now we're going to say, okay, what if it's not an equal sign, but what if it is an inequality sign? So instead of y equals x plus 3, what if it was y is greater than, or less than, or greater than or equal to, or less than or equal to? I'll show you all the differences for the greater than or equal to, less than or equal to signs. But first we'll just start with this one. Now, on your little square of graph paper that I gave you, make sure to give yourself an x and a y axis. Now, if you want to make a table of values, or if you're going to do slope-intercept form, pretend like it's an equal sign for the purpose of graphing. You're gonna graph it the same way as if it were an equal sign, but then the final look of it is going to be where we have some differences. If I did slope-intercept form, if this was an equal sign, what would I start with to graph with slope-intercept form? Pammy? Can anybody tell me? When we start with slope-intercept form to graph, Vincent, I start with? The y-intercept. Good, I'm pointing at the 3, right? The y-intercept, the plain number, is the only thing we know right now. 1, 2, 3 on the y-axis. And then from there we can count off our slope. Here, my slope, the invisible 1, means 1 over 1, right? So my slope. So we have to start with the y-intercept, and now from here I can count off a rise of 1, positive 1, a run of positive 1, a rise of positive 1, a run of positive 1. So up and over, right? In the positive direction because it's a positive 1. Now, here's the difference. Before we connect this, I'm going to actually do it in pencil so I can erase a little bit. If this were an equal sign, we would just connect our dots. So don't connect yours yet. Just wait and watch. If I were to connect these, and I made my straight line like that, what that means is that any point on this line, if I plug in its xy value into here, it would make a true statement. Okay, so again, let me say that again just to review. When we had an equal sign, when I graph my line, any point on that line that has an xy, for example, I'm just going to put the coordinates of this y-intercept. This is over 0, up 3, so this point is 0, 3. If it were an equal sign, then all these points, when I take its x and its y and I plug them into my original equation, it would make a true statement. That's what it means to be a point on that line. Let's see what happens if I plug this point in. Here's my x and here's my y. I'm just going to do it over here to the right. My y is 3 greater than 0 plus 3. 3 is greater than 3. Not true. Here's what we have to do, and I'll give you a little key for this at the end. This line is in the same position, but if it's just greater than or just less than, then the points on the line, as you can see with our little example here, they don't work. That doesn't make it a true statement. So, the way we're going to show that.
Krista?
Yes?
I'm sorry, do you have 8th grade?
I do.
Michelle's leaving.
Okay, she's in the computer room taking a test. If you could call over there.
Okay, thank you.
Thank you. A dashed line. Now what you might want to do is use your straight edge, make a line, and then go back and erase. A dashed line. This is the equivalent, guys, of an open circle on the number line. Think what we did yesterday with graphing. An open circle on the number line was for greater than or less than. The open circle on the number line, hold on, meant that that particular number where you put it, right? If this said, let me just do a quick example for you. If this said y is greater than 3, yesterday's type of work, and you got this, you would, on your number line, you'd have 3, you'd have an open circle, and you'd show all the numbers here. Open circle says don't include the 3. Think of this as an open line. It means the points on this line will not work. But there's going to be an infinite amount of points that do work. So here's what we're going to do to show all the points that work. This says y values are greater than x plus 3. From where my line is, right here on the y-axis, I'm looking where it crosses the y-axis. From here, where are the y values greater? Up or down? Let me ask again, look up here. This says y is greater than. If this is this line, this says the y values are greater. So from where this line crosses the y-axis, where are the y values greater? Up or down? CJ. Right? The y values get bigger as we go up. So the first thing I want you to do, now I'm going to do it in yellow so that we can still see through it, is we're going to shade. Don't spend a lot of time doing like beautiful artistic shading. You can do that in your homework if you want to. Make it look 3D or something. My artists. We're going to shade. Y upper, because I look at where the line crosses the y-axis. This says y values are greater than this line. Where are the y values greater? As we go up. Now, here's what this shading is. Everywhere we've shaded, every point in this shaded area is a solution. So how do you know if you shaded the right part? This is the equivalent, by the way, this shading is the equivalent of this arrow that we did on the number line to show, hey, y is greater than 3. Guess what? It's all these numbers that are bigger than 3. This is the equivalent of that arrow that we mark on the number line. These are all the points that will make this true. And I'll prove it. Let's pick one. Let's say I go just up one, right here. This point would be 0, 4. Let me do it darker. If I say 0, 4, that 0, 4 is in my shaded region, right? Well, let's test it out. If the y is 4, the x is 0, I plug them in for x and y, I get 4 is greater than 3. That's true. If I tried a different point, let's say we accidentally shaded down below. I'm going to ask you to test a point to make sure you shaded the right section. Let's say you shaded below and you go, oh, let me try 0, 0. That one makes easy math. 0 for y, 0 for x, 0 is greater than 3. Well, clearly that's not true. That means that all the points down here where that 0, 0 that didn't work, all of those are not true either. None of them will work. So again, the dashed line is the equivalent of an open circle. The shading is the equivalent of this arrow that we would do on the number line to show all the solutions. So, I know it's a little confusing. Let me stop here and give you some steps to follow. So, step 1. Oops. Graph the line as if it had an equal sign. So that's what I was trying to show at the beginning there. You're just going to graph it as if it had an equal sign, either slope-intercept form or making a table of values, either way. So you're going to graph that line in that same method. Step 2. You need to decide, is it a dashed line or a solid line? Dashed line goes with greater than or less than. Again, think of it that this dashed line is the equivalent of the open circle. So just greater than, just less than, it didn't include that number. It doesn't include the points on the line. So we dash the line to show, hey, the points on this line will not work. Solid line is for greater than or equal to, or less than or equal to, and it's the equivalent of the filled in solid circle. On the number line, it just meant it includes that particular number. On this, it would mean that all the points on the line also will make a true statement. So if this had been greater than or equal to, we would have just done this. And then if you pick a point on the line, it would work. Okay, so that's step 2. Step 3, shade above or below. Now, above would be for a y is greater than, or a y is greater than or equal to. You would shade below if it says y is less than, or less than or equal to. Because again, I'll uncover this in just a second. If we look at where the line crosses, we're going to say from this point, if it was less than, where are the y values less? Below, right? So that means down here. Okay, so we're looking at it in comparison to the y-axis. And step 4, pick a test point from your shaded area. Once you decide which side you're going to shade, I want you to pick a point from anywhere in that shaded area and plug in the x, y values to make sure it works. If it works, then you shaded the right side. If it doesn't work when you plug it in, then you shaded the wrong side of the line. Okay, so those are the steps you're going to follow. That's it. Although I just realized I should go back as I'm doing this. Okay, if I started with step 1, here's step 0.5 before we start. Or if you didn't want to put before. Step 0.5, get y by itself. Slope-intercept form, you'd have to do that. But also, you're going to want to do that first. Some of them will already be set up that way, but some of them you might need to get y by itself. Because if y is not by itself, first of all, you can't graph a slope-intercept form. And also, look at how we're deciding where to shade. We're looking at y is less than, not 3y is less than or greater than, right? But the y has to be by itself to determine the shading. So those are the steps you're going to follow. That's it. Do you guys want me to do one more, or does it make sense with the steps? Okay, looks like you guys are good and getting thumbs up. If you get stuck as you start working, just come ask. I'll need to bring you graph paper.